Ta-da. All right, let me. Yes, I have to share my screen. So let me change this for a second. Share. And then here we go. Okay, this is actually the book, but we're going to start here. So we are going to do exploratory EDA, exploratory data analysis. And oh, I am not sharing. Now I'm sharing. Okay, here we go. So exploratory data analysis, and this is kind of where we start asking questions about the data, start confirming our assumptions about data, and sort of refining what we can answer with our data. And some of the learning objectives, the two big questions that the chapter asks is, what type of variation occurs within my variables? So how do my measurements, I don't know, if you're weighing something, how does it vary from observation to observation? And the type of covariation that occurs between variables. So if you have weight and volume, how do those correlate with each other, right? As a linear correlation, right? Increasing or things like that. So again, variation between variables or features, how other folks talk about it, and between. How we're going to deal with missing values. So do we keep missing value? Sorry, how to deal with them. And I'm getting ahead of myself. I'm thinking of outliers, and then also a little bit of how do we work with outliers and things like that. And then, yeah, how we can. It briefly touches on models and how we can use them to explore patterns and data. So again, a little bit on the vocabulary. It's a variable, a feature, a measurement, however you kind of want to call it. It's basically your unit of your experimental unit. Active link to the lecture slides. Okay, sorry, I'll let you handle that, Colin. So whether it's a quantity or a quality, right? So is it categorical or is it continuous? The value that was collected, the observations. So observations, how I think of it, is that row of a measurement or things like that. How do we usually organize it? Well, tabular data, and then one observation per row, one variable per column, one value per cell as our definition of tidy. I recognize these vocabularies might change from field to field, so you are welcome to fill in the blanks there of how you think about your data. So, but a general one is variation, right? So the tendency that values change between measurements, right? So if I weigh myself today and I weigh 70 kilos, and tomorrow I weigh 71, and I do that for a month, and there's plus or minus 2 kilos, that's pretty consistent. But if there's plus or minus, I don't know, 10, there's more variation in each measurement. And then categorical values, basically, kind of like the name says, so it's just a category. Do we have A, B, C units, or whatever we're trying to measure, or species A, B, and C, or feature A, B, and C. So in this example, the book leads us through the diamonds data set, and we have a couple of categories. We have the different cuts. So is it a fair cut, a good one, or all the way to an ideal cut? And these are arbitrary. We could call this bad, medium, better, excellent, perfect. These are arbitrary categories that we've designated in our study or our measurements. And then we have continuous variables that just take it could take integers or doubles, right? And it's both numerical, so it could take 1, 2, 3, 4, 5. Or if we're measuring more precise, we're saying, because if weight, for example, is a double versus diamond, it's a full integer, because the diamond is either there or it doesn't exist or it doesn't exist, right? So, and then how many we have of them. So in a data set like this, we usually want to understand the distribution of how many, for example, here on the caret or the cuts. So we do a little histogram and we say, hey, let's look at that distribution. Let's see if it's a normal distribution, if it's skewed to the right or skewed to the left or things like that. And here with this histogram plot, we see that there's high concentration or high count between 0 and around 2.5, and then there might be a lot. I don't know. I guess 0.75 1 caret, but there's a lot of things wrong with it, and it's the bin width is it's too big. So 0.5, that measurement is not really showing in detail what is going on with this data. And a couple of things that the ggplot package functions that the ggplot packet has is geom frequency poly or geom histogram. This one up here is histogram. And we say, okay, let's visualize this a little bit different. So we're going to filter. We've identified that it kind of stops at around 3. So we're going to filter all of those that have a caret less than 3. And then we've called this subset data set smaller, and let's plot it. So now we have very nice colors, and we see that there's a high count of ideal and cut diamonds with, I don't know, I guess this would be at a 0.45 carat, for example. And then we have fair, this purple one, fair cut carats, cut diamonds with a carat of 1. So there's a high count there for that category. So with these visualizations, we just start asking these questions. What's the most common value, and why? Why are some values rare, and do they match the expectations that you have of the data, right? So I don't know anything about diamonds, but I would have at least, I didn't even know almost 0 carat diamonds existed. So that for me is something that I commented with no assumptions and surprises me, right? And I'm like, well, why is that? Is it that difficult to have higher carat diamonds? But again, I don't know anything. So it's those type of questions that we start asking to familiarize ourselves with the data and help us understand the patterns with it. So this is a nice, and it gives us a count, and it gives us kind of how they overlap by the category. So for example, up here, we don't have any category. It's just a lump. But then when we break it down by the cut categories, we start seeing patterns. But then we decide to go and use a histogram again, but we make it a smaller bin. And then we start seeing very interesting patterns where we see that there's this sort of there's carrots at specific, diamonds at specific carats. So at around, for example, at around 0.5, you have a high count. At around 0.75, you have a high count. And around 0.1, at around 1 carat. And then it just tapers off, right? So it's pretty rare to find a diamond with let's just call this, where my cursor is, 0.87 carat. There's just a low number of carats that are produced that way, right? It's easier to say we're going to have a 0.5, a 0.75, and a 1, and a 1.25, and things like that. So we start seeing clusters of data. So this is this is a cluster here. This is another cluster at 2, and things like that. And these subgroups or clusters, we just start asking, why is it that way, and what can help us explain those clusters, and what might be misleading of representing the data this way, or visualizing it this way. Okay, this is the end. So we can use from ggplot, Cohort, Cartesian to zoom in and look at unusual values. And for example, here at this tail end, we see a bunch of small ones here. And then if we squint our eyes, there's one at 0, a couple count there at 0. Yeah. So that's one way. So we start visualizing different ways. We zoom in, zoom out, and start thinking about why is there this. This is something that the book kind of emphasizes a little bit more, but there's a count here in 0. So why is there those zeros there? And we have to understand not only the data, but the metadata. That's something I would add to this chapter. How were those measurements taken? What's the data dictionary? What details can we learn from this? Why do we see, for example, NAs? And why do we see NAs maybe for a certain carat or value versus another, or just things like that? So understanding the data is important, but I would add understanding the metadata and an added layer of how this data was collected to inform what NAs mean and how are we going to handle them. So a simple way is just to mutate, put in if-else conditions, and say, okay, if they're less than 3 carats or more than 20 carats, you're going to add an NA at column Y. And then ggplot just gives us, you can still plot it, and ggplot is just going to give you warnings that it doesn't know, it's not going to plot those NA values. And sometimes you might you might want to handle it, but others, it's maybe 10, 5, and it's fine for whatever you're trying to do. So the other thing is, so that was just variation and kind of values in your main observations, but then you have a covariation between your different variables. So how do they vary? And if they vary in a related way. And I think there's many ways that to visualize covariation. I think something the book doesn't talk about is, building a covariance matrix, and saying and seeing Pearson correlation values or things like that as to like how correlated they are or not. So the book is very visual in that sense. So we're exploring data very visually. And the ways to do this, a couple ways to do this when we have categorical and continuous variables, we can visualize it through a box plot. And I think I opened, nope, I went, sorry. So yeah, let's just open that for a second. This is super cool way of doing it, and it's through these, we have box plots, yes, so that's categorical and continuous, but adding the element, I'm going to scroll us down here, where we're seeing that continuous element and then the distribution of that data within that category. So that's one way of visualizing that. And then when we have categorical and categorical data, just doing geom counts and geom tiles. I think the book there's a couple of like two-dimensional histograms with this, with little square bins or hexagonal bins, which is pretty cool. And then continuous data. Continuous, for example, if we had, again, weight or carat and price and all of these things, we can, sorry, carat and price is categorical and continuous. Weight and volume, two continuous things, or temperature and precipitation. We would do a scatter plot with geom point, and then maybe draw a simple linear regression, draw a line and see, is it going up or is it going down? Is it close to the line or not? So things like that. Other ways are doing principal component analyses and things like that, but that's a little bit more involved. So EDA is all about finding patterns, and it's about asking ourselves, is this pattern due by chance, right, or random chance, or not, right? Is it actually a pattern that's being driven by some of the things that we're trying to understand? How can we best describe the relationship and those patterns? How strong is the relationship implied by the pattern? So, oh yes, precipitation and temperature are correlated, and there's a linear correlation there, but how strong is it, right? Does it fit that line very strongly or not? And then what other variables might be affecting that, right? So when we have correlation, we might have to say, well, temperature and precipitation, but it depends on the time of year that those measurements were taken, right? And things like that. So you have to start thinking of what other things are going to impact the patterns that you're seeing. And then this last one, does that relationship change when we zoom in? When we look at subgroups, does it still hold or not? Or are those the broad patterns that we're observing at a population scale or whatever, are they stronger in some subgroups than others? All right, so a way to ggplot is excellent for this because it provides a lot of simple ways to just throw in one of these functions and start seeing those patterns. We could also do it in base R, but this is kind of what's in. So I've never seen this eruptions. Oh, this is Yellowstone data. So faithful Yellowstone, Old Faithful eruptions. So how many eruptions, and then the count. Sorry, I guess, yeah. And then John's Crazy Way, I've never seen this. I've never seen the aesthetics just hanging by itself. It's pretty savage. Oh yeah, Colin, the core package is awesome for correlations. Yeah. Heat maps are pretty in nowadays for correlations. And I think the core package has one of those features. So bright red, highly positively correlated or negatively, whatnot. Yeah, this is actually, it's kind of short in that sense, but yes, these resources actually, the R graph gallery is excellent for this, because it takes you and it has, I can't find it right away, but it does have um, like a dichotomous key where you start asking, so, do I have categorical? Do I have continuous data? Yes, no. And this is, so it guides you very well into how to look at those things. So if we look at, you have ways of visualizing correlation, ways of visualizing groups, some line plots and things like that. So these are excellent tools to incorporate in your EDA analysis. And violin plots are very in nowadays. They're very informative and things like that. So yeah, any questions?
I'll open it up to the group if anybody has any questions here, or if they have any other comments.
I find data exploration really challenging because sometimes I jump into and get into the nitty-gritty before like getting kind of a global view. Does anyone have some recommendation what they usually would just do before they get too much into details? Do you know what I mean? You have like already a question in mind and start like tidying your data towards that, but maybe there's something else. You should just like look at the data, right? That's the whole purpose of EDA. Any recommendation in that regard?
I think.
Go ahead, Bolivar. Go ahead.
No.
I mean, it's going to depend on your specific use case too, because I like the data that I work with is usually the same over and over again, and so you're like, I mean, I should always do EDA like every time I get a new data set, but usually some of the patterns that I see are pretty usual, so I kind of, I don't know if I want this recorded, but I get lazy because I know they are the same. But I think having like a standardized practice of any data set that you get is really important. I shared the SCIM-R package. I like SCIM-R because it's literally just one function. You run it, and it really, really quickly just gives you an output of pretty much a good chunk of like EDA stuff to look at, right? Like, what are the missing values? Here are some basic like histograms of it for the numeric variables and whatever. And I scan through that and make sure that that's like makes it usually pretty good. But yeah, it's just usually having like a standard practice and try not to be lazy in certain situations, because I certainly have been bitten in the past when I don't check for outliers or check for null values. Or I guess the other thing that I would say is just like have those like silly mistakes in mind too, because those are the ones that you always get bit on, is like, oh, I just made this silly mistake. Oh, NAs are available. Like always check for NAs or have a process for that. But I don't know. I'm interested to hear what other people have, because that's an interesting question.
Yeah, I work a lot with ecological data, so it should be or like field data, so it should be the same, but it's never the same. There's always someone else collecting it, because you know, or things like that. So as much as I would like to have a very nice pipeline, there just isn't. Like I have to look at it and then say, well, we don't have a lot of observations, right? So I have to keep those outliers. or like what I'm gonna, who were those outliers? Because, you know, say you have an N of 100 and you have 5 outliers, you can say, hey, who were these and what happened and things like that. But that's sometimes not feasible when you have many and a greater number. But I think also taking a step back and maybe sharing it with someone else, of like, take a look at this. Because I've definitely been in the nitty gritty and trying to get it to work because I have a question or an end goal, and it's in a meeting or something that I then like share it. I'm like, oh, I'm like doing this. Oh, but why didn't you think of that? Or why didn't you think of this? Oh, of course. So kind of a fresh set of eyes can help with getting a bit more perspective on what you can ask of the data. So I guess, yeah, flexible approach. That's my.
Okay, awesome. Thank you.
Yeah.
And I think like the other thing too is like there's just so many, like EDA is such a like it's just a common practice that most of us do, and like there's just so many packages out there that like have specific use cases that you can kind of lean on, like I said with like core and skimr. But then one of my coworker who's actually on the call today shared with like this one called, I think, Amelia. I haven't used it too much, but it's for like detecting missing data, so that's really good too. I'll share it. We've been kind of using it a little bit with some of the workflows that we have. I kind of like it. It certainly has some utility. I think there's also, and we've been kind of moving more into this, like if we know that there's common patterns that are going to be within our data, especially when we do like exploratory analysis, it's like we should probably move to more automation of our testing of things that we know are like clear errors, right? So like using test that to write expectations for our data. So like we would have like a general range of what we would expect for our data to be in, or certain expectations of our data. And so what we can do is we can automate those tests to be like, okay, if values are clearly outside of this, maybe look into it further. So it's kind of like automating some of that exploratory stuff if you have data that you're consistently getting. And I know that's not the case for everybody, but like for us, our data doesn't, I shouldn't say doesn't change, but it's like the same structure over and over again. You kind of know what those structures are, so you can build in some type of framework to double check, to be like, hey, there's this clear issue, explore this further, and you should automate that if you can. I'm trying to think. There's also another one. There's also another like data validation one too. What's it called? It's like,
yeah, I think it's point blank.
That's it. Point blank.
Yeah. Yeah. That's like data integrity and validation. I have never worked with that, and I just wanted to create a data dictionary with it, but I always got some issues that I couldn't figure out for me with like formatting the table. But yeah, I have never worked on the validation side, but that would be also package. I was just thinking if that's what you were talking about.
Yeah, I've played around with point blank. The thing about like doing like the data validation stuff is just like, how far down the rabbit hole do you want to go? Like there just gets to a point where you're just like, it's just diminishing returns of like, okay, yeah, I could use this as an automated test, or I could write all these expectations, and then before you know it, you're like, I'm not doing analysis anymore. I'm doing data engineering stuff. And so it's, for me, my experience with point blank was it's really nice. It's really convenient, but I just felt like for the work that we do, it was too much overhead for what we were getting out of it. So, but it might work for other people too, beyond what we do. So, does anybody have any experiences where EDA led to something interesting or helped them out significantly? Does anybody have any like stories or? Anything that they'd be willing to share where EDA kind of helped them out significantly?
No. Well, I do have to add that something that the book doesn't touch, and I think is very important too, is which I guess gets to that, like, oh, the assumption of normality, right? Is it normally distributed or not? And how are we gonna test that? Right? So it's very visual, and that it's nice, but the whole throwing in a Shapiro Wilk test and things like that to say, okay, is it actually not? Do I have to log transform or not? And things like that. I think EDA should lead you to that, right? Of answering very clearly, do I have a normally distributed, data or not? And then inform the necessary transformations that you need to apply to proceed with your statistical test. If it doesn't do that, then I don't know. I don't know what you were exploring in that sense. So
Yeah, absolutely. Anybody else? I think I had a couple, like one of them, it's like outliers for us, because outliers are just clear sense that something's wrong, like a system collected data incorrectly. It's a value, it's a row that's not as expected. Maybe it should be, removed or addressed in some other way. But the other one too is I teach a class looking at teaching like journalists and broadcasting majors to do like use sports data to write data stories. And outliers are important in those cases. So a lot of that class is focused on doing like EDA methods, like basic visualizations, looking at distributions, looking at variable relationships to find those outliers, because that's the story, right? It's not, yes, it's interesting where you do see some relationships and stuff but like where the really interesting stories are where the outliers are. And so it's interesting where EDA comes into play with that, to be like, listen, you can find really interesting stories if you just look at variable relationships or you look at the variation within the data, and you just have to identify what that story is. And so I try and espouse to them to be like, EDA is really important because that's where you can find the interesting storylines to write stories that people are interested in hearing about. So, but that's a soapbox thing. Cool.
One other thing I just found interesting with this example about visualization using violin plots and bar plots. I think this is not strictly EDA, but visualization. Like I was in academia, I'm still working at the university. But one of the interesting things is that people expect certain representation of data, even if it's suboptimal. Like bar charts is like a typical thing. Like you start learning anything about representation of data and bar chart is the worst. Like I was working on something called gene expression data. And when I was doing my PhD, that was just all bar charts. And I couldn't convince my supervisor that we should, either just actually plot the data because there were 3 or 5 measurements. So it would have been really easy, or to do a box plot. It was not possible. She was too afraid about that it would be just be rejected because of the expectation of the reviewers. And so that's something to keep in mind when you want to show data to other people, because if they have too much cognitive overload because they don't even understand the data, they might just reject it. Yeah.
I totally agree and have experienced that. If it happened with me with the violin plots, and it was like, why isn't this a box plot? I mean, a box plot, yes, right, fine, but I guess the compromise was, merging these box plots with violin plots, but I guess in academia, it's just also the flexibility. Like sometimes you publish because you wanted to appease the reviewer, right? So you have a better chance of telling your story maybe with a, kind of plain language scientific communication or not, but then sometimes the discrepancy between the paper, you're like, so.
I mean, that resonates in business as well. I mean, there are certain things that people are familiar to consume. And so it's like my example would be like, because I do a lot of trend stuff. I do a lot of time series stuff. Like that's like a lot of my work is looking at time series. But the idea of like taking your time series and then like stacking your time series. So like say you're looking at a year and you put them up, like that was just like completely like new and radical to people. Like they were just like, well, wait a minute. I don't see the trend anymore. Well, no, you do, but now you're actually making comparisons across the years. So that was kind of like a step forward. But I found what's really beneficial is like when you share a graphic like that or a complicated graphic, and this is outside of like a paper and like having it as like a static thing, but more of like a presentation, to really just take a second and say like, okay, what can this graphic teach us? Is like the one statement is like, what's the one thing that I want to get across to you, and saying, yes, this may look complicated, but let's just talk about what is this telling us? What is this teaching us? And so it makes it a little bit more accessible if you can get that like single point out, rather than being like, here's a bee swarm plot with like 5 different categories of things and a distribution, whatever. It kind of makes it more accessible to be like, you as the communicator to be like, this is the one thing I want to get out of this, or here are the 2 things I want you to get out of this, and this is what we can learn from it. But I know that's different than like getting a paper through, a reviewer and in an academic setting. But it aligns with what my experience in like business definitely is. It's the same thing.
Yeah, I think that's
cool. Yeah, I think I think unless anybody has any more comments or questions, I think we had a really good presentation there. So thank you very much, Bolivar, for leading us, and then thanks for everybody for contributing their thoughts and everything. And I guess that's pretty much it. I guess we'll give everybody their time back, and we'll see everybody next week for communication. So all right, everybody have a good rest of your week.
thank you.
Thank you. Bye.